Continuing our discussion of heap buffer overflows with Windows, I wanted to look at another slightly more complicated program. Now, in this program, we are going to use three buffers. So it starts out the same. I'm going to create a heap. I have 3 pointers. I allocate 16 bytes into buffer 1. Then I allocate 16 bytes into buffer 2. Then I'm going to free buffer 2. After I've freed buffer 2, I'm going to go ahead and put 16 Bs into buffer 1. The 16 Bs should completely fill that buffer. And we talked about the look-aside list. And we said for the look-aside list, we have 8 bytes. So we have the previous pointer, that's 4 bytes. And then we have the next pointer. After that, I'm going to input these 4 bytes, which is an address. So I have this address. Now I'm going to leave it as an exercise for the listeners here to figure out exactly why I chose this particular address. And I will say this much. This address is specific to the version of Windows that's being run, also to the service pack. We'll talk a little bit more about that later. I don't want to give away the plot just yet. So here we have the address. Now, remember that this is stored in little endian format. So because it's stored in little endian format, you need to read it backwards. So this address is actually 71AB400A. After we have overwritten our buffer, we've overflowed buffer 1 into buffer 2, we then reallocate buffer 2. And then we're going to allocate a third buffer, and we're going to give it 16 bytes. Now, these bytes that I've input here are actually some shell code I downloaded from Shellstorm that is appropriate to this particular version of Windows. After I copy my shell code into the third buffer, I'm going to call free on that buffer, free on buffer 2, and free on buffer 1. There could be a problem with buffer 2 because I've overwritten the pointers on it with what I put into buffer 1. And there's a reason why I chose a particular address. And then I call free on buffer 1 and I return 0. All right, so we are going to take a quick break. And when we come back, we will look at this inside of the Immunity Debugger.